judgment if you don't remember it now. Function-y stuff. What else besides functions? Like different. Go beyond functions. What else is in that packet? Intersections. Solving. How do we find intersections? Solving systems of equations. Yeah. Andrea, what were you thinking of? Yeah, trig, right? So we have the unit circle, the basic stuff, but then didn't you guys also have stuff with, were any of the trig identities, like properties and formulas in there? No, I don't think so. Solving trig equations, though, right? Like sine of x plus 2 equaled, that would be impossible. 1, there you go. Sine equals 1/2, that's a thing. So yeah, some trig equations, and then solving trig equations, or solving equations with trig, and then unit circle. Good, what else? Logarithms and exponentials too, I think, right? Logs and exponentials. What else? Equation of a line. Ooh, what is the calculus form of a line? There's slope-intercept form, there's standard form. Point slope, what's that formula? Y minus y1 equals? Booyah, that's the calculus form of a line. Graphing lines, maybe? Slope a little bit, maybe? I don't know. How about fractions? Where were fractions in the packet? In my head, it's one of the things you've seen the most, and yet it's one of the things people miss the most on the quiz. Well, yeah, people miss the unit circle too. But complex fractions, did we find that page? Complex fractions. I have a trick for doing those. Did anybody not like that page at all, the complex fraction page? Oh, you liars. Thanks, Abby. Okay, let's start there. I mean, we have the limits, right? The limits were part 2. Did we miss any huge things, guys? I think we got most of it. Can we go to the complex fractions? Where did it show up? Page 2? Oh, the awkward numbering. Yeah, one of these days I'll change that. It's after even and odd? Here it is. Okay. You might not do these the same way I did them, especially if you didn't have me as a teacher, and to be honest, I don't remember what Mr. Che does. Or did, I should say. Because we definitely saw complex fractions in pre-cal, but that doesn't mean that he did the same trick I did. Can anybody verbalize for me or explain for me how I do complex fractions? What am I doing in every single one of these problems? Kyle, start over again. What do I do? What do you mean common denominator? Like there is no plus or minus. Like it's one big old fraction. Oh, so we're looking at each of the little pieces. We're not looking at the entire fraction, but each of the different components? Okay. So x plus 2 is like the common denominator of each of the little pieces. A is the common denominator. Actually, he's the only denominator for all of those pieces. Is there anybody who had more than one? Oh, this guy, right? So the common denominator would be x and x plus 1. This one, I guess he just had 3x minus 4. So yeah, I find the common denominator of all the pieces. And then what, Kyle? Yeah, because multiplying creatively by 1 has to be same top bottom. Good. And then what? And then I solve. And if you realize solving one big fraction to one big fraction, I learned the word for the big fraction bar the other day. Viscont? I'll find it. Anyway, some random 7th grade teacher made it their life goal for the year to have their kids know the name of that. I don't know why. It was weird. But anyway, look at the big fraction bar and take the numerator with numerator, denominator with denominator, distribute. And as you do, what should happen if you've done it correctly according to my shortcut trick? The complex fraction after one multiplication is gone, right? No more complex fraction, no more complex fraction, no more complex fraction, no more. Now, is my trick the only way of doing it? No. Can someone tell me another way of doing, for instance, since Kyle said it, number 86, just because some of you, the shortcut isn't worth it right now. It's worth it for you to be able to do it right. Kyle, you mentioned 86. What was that problem? What's another way of doing this besides my trick of x plus 2, yay, multiply, top, bottom, be real careful, go. What's the answer? Multiply by the reciprocal. Now, multiplying by the reciprocal would take, or would need us to have the numerator, right? And why does this get messy? Can I just flip these two and say, yay? Because it's 1 over this whole thing, right? So technically, what would we need to do to be able to multiply by the reciprocal of that dude? Get common? Yeah. So either way, you're kind of dealing with this whole little like x plus 2 over x plus 2 thing. Just this way you're dealing with it. Divide is multiply by reciprocal, and then you're doing it. My way, you're kind of just doing it earlier. But either way, I think the easiest way to go about this problem is to get common denominators or to multiply in a way that you get rid of denominators. Because then we would end up, you guys okay if I go fast with distribution and all that jazz? So that's my numerator with common denominators. And here's my denominator with common denominators, 5x plus 10. Still not great, but it's about to get a whole lot nicer. Because then we get 5x plus 20. And now we can go ahead and get to, I guess we could pull out a 5, huh? You guys okay if I do that? I'm putting parentheses wherever I need distribution. So that'd be 10x. Lo siento, I pulled away the 5. It's been a long summer. Pulled away the 5. What should that be? Thanks, guys. I'm just modeling making mistakes. It's okay, it's okay. Is that the same answer as the other one? Yeah or no? Whoa! What did I do wrong? Did we write it wrong? That's awkward. Anybody catch a mistake? Two x plus 4 minus 4. Oh, I never flipped it. Thanks, Kyle. It was 1 over, wasn't it? I had too much fun simplifying. Okay, so then stuff cancels out. See, there's so much when you do it this way. So many places to get stuck. Now, once again, if this is the way your brain gets, it's okay. Ah, the whole reason we did this was to flip it. There we go. Well, that was a lot easier than I made it. Okay. But do you see how there's a lot of places to get lost? So, if this is the way that your brain gets, Mariah, you were totally right. Multiply by the reciprocal, but then common denominator, and then don't forget to actually do the reciprocal. And then, so anyway, that entire page, I just wanted you guys to realize my trick is not the only way of doing it. I just think it's the easiest, so that's what I do. Does that make sense? Okay. But multiplying by the reciprocal, totally fine. Okay, for the whole rest of the packet, to be honest, there is no one single page where my way is different than what you might have learned in the past. I don't think. This is the one weird page where I literally do it very possibly different than you've ever seen before. So now it's up to you guys. What do you want to see? What do you want to talk about? We still have about 12 minutes. I'm ready to go anywhere. Kyle. Yeah.
So there could be like a question on the quiz.
If there's a question on the quiz from the packet, using this as an example, I could have it simplify a complex fraction, but I doubt it would look exactly the same. Does that make sense? Yeah. Now, all that to say, this is a good thing for the entire year, because some of you are like, how do I study for this quiz if I have the whole packet done? If I were you, I would peek through it, or have someone else peek through it, and any problem that had lots of colored marks, I would have someone like write it on a paper for you, like a friend or a parent, or write it on a whiteboard for you and see, hey, can you do it right now? What's the problem of just looking at it and being like, oh, that's how you do, that was my mistake, this is how you do it right. That was my mistake, this is how you do it right. Your brain's already figured out how to do it right. But if you're given the problem from scratch and you're supposed to do it again, now there is a danger. A few of your brains are going to just memorize the problem, and as soon as I give you a different one, you're going to get lost. But if you're in AP Calculus, most of you just need practice with the types of problems that you tend to make mistakes on. And to be honest, kind of just take a problem from here, from here, from here, from here, get it on a whiteboard, get it away from the packet, get it away from the answer key, get it away from the mistakes that you made and then fixed, get a brand new, or at least a nice new copy of the problem. Try it again. Does that make sense? That's probably, or go on the website. Isn't there like a blank copy of the packet? And just look through and find gross ones and be like, yeah, let me try it again. And then check the answer key and be like, oh, I made the same mistake. Or, oh, I forgot how to do that. All throughout the year, that's going to be a great technique. You don't necessarily need new problems. You just need blank problems to try again. Does that kind of answer? Cool. Okay, sorry. Does anybody else want me to go anywhere in the packet? Yeah. Even though the pages are gross, guys, do the numbers go in order? Did I get that at least right? Okay. 54. Okay. This one is gross because it has a square root of a squared, which needs like an absolute value. So that's why there's this little weirdness over here with the plus or minus x. I'm just stealing the blank copy, kind of for the reason that I just said, as far as you guys have the answer key, you've been able to look at it already. What's our goal for this section, Kathleen? Oh, how do we find horizontal asymptotes? Ooh, something to study, something to highlight. You guys need to go through and think about if she asks me horizontal asymptotes, do I know degree tests, limits to infinity? You can do it either way. Degree tests are fine, but technically at the end of last year we also saw that those are limits to infinity. Degree test. How do degree tests work? Either the top wins, right? Or the bottom wins. What makes somebody win? What are we looking at? The degree is the technical term, right? So it doesn't matter whether it has a number in front. It doesn't matter how many terms it has. It matters the degree. What's the degree of the numerator? 1. It's a linear, right? What's the degree of the denominator? Technically linear also. Why? Square root of a squared. Now, can we take the square root of this? No. Oh, because that's not a squared. No, if that was x squared plus 25 and you tried to square root it, you're killing. What are you killing? A puppy? Yeah. Anyway, we can't actually say what this equals, but we can say what the degree is. So there are a few different ways of doing it. One way, to be honest, one way is to think about what we would call as the, isn't it called the growth model? We didn't learn this in pre-cal. But one way is to basically say, hey, this is really, 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 really close to negative 3x. And this is really, really close. Like eventually, as you go to infinity, which horizontal asymptotes do, there's all this weird stuff in between, but then it's like, what does it level out to be? You can technically say this guy is really, really close to, we're going to use negative 3x for him, and we're going to use plus or minus x for him, because the square root of a squared. So a cheater trick is to ignore all the lower degree and just think about, okay, if I was to compare this to somebody who's basically the same as I go to infinity and basically the same as I go to infinity, that's what this trick was for, you can actually get the horizontal asymptotes. And the horizontal asymptotes will be y equals negative 3. Well, actually, that's a positive 3 and a negative 3. However, there is an algebraic way of doing it. Technically, you could say the degrees are tied. Tied means the ratio of the leading coefficients, which means negative 3 over plus or minus 1. So negative 3 over a negative 1, negative 3 over a positive 1. So it is a tie, ratio of the leading coefficients, but the problem is any square root of an even degree, you need a plus or minus. You're going to have two answers, not just one. Does that kind of make sense, Kathleen, as far as a shortcut? The algebraic way isn't quite as nice, but the algebraic way is actually getting rid of what we don't want by multiplying top and bottom by the highest degree. Hello, sir. Good.
How's everybody doing?
I have a quiz on Wednesday, so we're working hard.
They love that.
Yeah.
That was
But
the
then senior
criteria.
retreat, no homework over the week. Oh, it'll be great.
Nice.
And juniors just get to benefit. So honors kids saw this. Regular kids, I'm not totally sure, but we distribute the highest degree. Can anybody tell me why I'm doing the square root of x squared and not just x? Even though they're kind of the same thing. Yeah, why? The plus or minus. Yeah, because otherwise we'll just get one answer instead of the two. So then the weird thing is when you go and simplify all this stuff down, you'd have that negative 3x over that square root dude. And you'd have 1 over that square root dude. Down here, he actually gets to come in and join. So we have 1 plus. Does anybody remember what happens? Now, this is technically a limit problem. I know we haven't really reviewed limits. It's a calculus. But what happens if you're taking the limit? What am I doing? X goes to infinity. Yeah, we're going to infinity. Sorry, horizontal asymptotes. What happens if you have someone on bottom? Does anybody remember? Goes to 0. So technically all of this would go to 0, and you would end up with square root of 1 is just 1. And the only way to simplify this is to split him up and say sometimes he's a negative x, and sometimes he's a positive x. Because that's absolute value of x or a plus or minus. So it gets you right back to the shortcut. So all that to say, you don't have to do any of this work. There is a shortcut that says, hey, look at that square root, look at it with the x squared, it is a type. So do the ratio of the leading coefficients. But whenever you have a square root of some sort of even degree, you have to think plus or minus. Is that cool? For like simplifying it all down? Okay. What else do we have? I'm ready. 5 more minutes. Just throw me a number. Kyle. 65. How many people love logarithms? Remember last year they're just baby puzzles. If you like puzzles, if you like games, they're just baby games, baby puzzles. But how good are you going to be at a game without luck? How good are you going to be at a game if you don't know the rules? Not so hot. How are you going to win a chess game if you don't know how to move the pieces the right way? How are you going to win a Sudoku if you have no idea what the restrictions are as far as what numbers to put in and how? Same thing here. Kyle, I'm pretty sure the directions are simplify, yeah? Does anybody remember there's this really cool product of logarithms that if you have a quotient, you're able to change it to be minus. That's a cool property of logarithms. Why is that cool here? Because what can I change this to be using that? Now, struggle is you won't know what you have unless you remember some other key facts. Like, what is any logarithm of 1? Any log, ln or log base 10 common log or log base 2 or log base 5 or log base 7. What's any log of 1? Because base to power, any base to the 0 power will always be 1. You might have forgotten that logarithms, there's an exponential way of writing them. Anything to the 0 power makes 1. So that's just 0. Does anybody remember what's so cool about ln of e? Any log of any base to the exact same is always 1. Why am I saying that? Because who is ln? Log base e. 0 minus 1. Dun, 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 dun. Is that cool? Guys, we have one more minute. Period 6 is going to have their own unique questions. So some of you might be like, I didn't get to ask my question, or I would love to see some more worked out with your explanation along with it. Check out the YouTube video, link via my website, and look at period 6s or watch period 6s. And if I ever go too slow, you can put me on double speed. And if I ever go too fast, you can put me on half speed or somewhere in between, which is kind of cool. But what's your job tonight if we have a whole nother class period? Yeah, get your highlighter out. Start going through the topics and be like, okay, what do I need to look at? What do I need to focus on? What do I not like? And if we run out of questions tomorrow, what am I going to be able to start doing? Throw out random problems and see how you do. We'll get some little whiteboards at the desk and we'll just try them. Does that sound good? But first of all, I want to answer your questions. So look through your packet, get a highlighter out, and start looking at what you need to be studying. Now, is it a little bit rough start to calc? Quiz on Wednesday? Yeah. But remember, starting at, I think, 7:10, donut holes and coffee will be available in here Wednesday morning if you want to come study. It'll have to be kind of quiet because I'll have to see how many seniors are in period 6 and stick them in the back with their quiz or with their version of a quiz. And I'll be here today after school, tomorrow after school, at least until 4. But remember, we get to rest Thursday, Friday, and no homework over the weekend. Cool? All right. You guys have 25 seconds. Give high fives to everybody in your group. Be like, we got this. Day 1 of school and calculus. Well, maybe we don't got this, but God's got us. I know. It like dims and then it